Hey guys, here is 9.5 part 1. I seem to have come down with a little bit of a cold, so I apologize in advance. But today we're going to start talking about ways to represent points on a different coordinate system than you're used to talking about. We have talked, probably your entire life, you guys have talked about the rectangular coordinate system, which is your basic XY. This would be our x-axis, this is our y-axis. That's our rectangular coordinate system. So in this section, we're going to cover a second coordinate system called the polar coordinate system. And I have this, is actually in the back of my room. You guys have probably seen it. It's on one of the whiteboards in the back. But our polar coordinate system is shaped like a circle, and it is based upon what you probably would see and look like the unit circle. So when we talk about the polar coordinate system, it's very similar in some ways to, the coordinate system that you're used to. There is an origin right here in the middle. And this origin, which we usually call origin 0, 0, is actually called the pole. So in a polar coordinate system, the origin is called the pole. So I'm going to refer to the origin as the pole, and that's just the middle. That's what we're talking about. Now, from the pole, you have something right here. It's called the polar axis. This is like your x-axis on your xy coordinate chart. This is your polar axis right here. Polar axis. Like I said, it's very similar to the x-axis that you guys are used to referring to, and that's where everything's going to begin. It's our initial. And then from the polar, you to form an angle, like if you're going to go up, this is positive. If you're going to go down, this is negative, just very similar to what we've talked about. The distance from the pole, the middle, to the origin, to an angle that is on the outside, any of these angles out here, is called your R value. It's a directed distance. This is your R value, directed distance. So for a second, guys, let's talk. If you look at this directed distance here, and then we have our polar axis here. And if I were to draw a dotted line right here, what kind of a triangle is formed right here? Well, that would be a right angle. And from our previous chapter that we've talked about, we're using our right triangle trig and stuff like that. If I were to ask you guys, if we were using our x, y, and r, this would be my y value. This would be my x value, left and right, up and down. And then r would be our hypotenuse. So again, this is all based upon the right triangle trig stuff with our unit circle. So instead of having an xy coordinate when you are when you are plotting points, you're going to be given an r comma theta, and all that is the directed distance, and this will make more sense in a minute. And then this is the angle on the unit circle, or on the polar coordinate. This is the angle. So you're going to have a directed distance and then your angle. So just say we had this point here, and I'll tell you how to get there. But do you remember from previous lessons, like in chapter 4, this is pi over 3. I could also add one whole circle here and end up back at the same point. And I'm still at pi over 3, but that value is not pi over 3. That value would be pi over 3 plus 2 pi, which would be 6 pi over 3, so 7 pi over 3. And remember, we could add another whole circle, or we could subtract a whole circle, and just keep coming back to the same place. It'd be the same exact place, but the number would be different because you're adding and subtracting circles. If you guys remember, that's called coterminal. So we're going to use that concept, and we're going to be able to name points on the polar coordinate system with different names, like different angle measures and stuff like that, but it'll be the exact same place on the coordinate system. So this is pretty much what I just talked about. Polar coordinates are written here, like I told you, r comma theta. It's going to be a directed distance, and then your angle measure. R is your directed distance from the origin, the pole right here, to whatever point they're talking about. And then the directed angle is counterclockwise from the polar axis. What that means is you're going to start here. The polar axis is 0. Counterclockwise means you go up. So it's positive, and then if they give you a negative angle, you're going to go down. Same thing that we've talked about before. So let me talk to you guys about how to plot a point, okay? If I gave you the point 2, 5 on an normal XY that you guys have seen a million times, you would say, okay, I go over 2 and up 5. 1, 2, 3, 4, 5, and here is point P. You cannot add or subtract anything to the point 2, 5 and end up in the exact same spot. This is a unique point. This is the only point that will exist at 2, 5. You can't add, subtract, multiply anything to 2, 5 and end up in the exact same point. So what is different here is that when you are on the polar coordinate system, you can end up at the same point various amounts of ways by adding and subtracting, adding and subtracting one whole circle, which we'll talk about in a second. So now I'm going to tell you guys, okay, go ahead and plot this point. Right here, go ahead, go. And you're like, huh? What does that mean? Well, let me show you how easy this is. Remember I told you this is the angle that you're talking about, and then this is the directed distance. We always start at the pole. Directed distance, S-T-A-N-C-E. Okay, so here we go. Here is my origin. Here is my pole. And I want the angle pi over 3. Well, where is pi over 3? Do you guys agree with me that pi over 3 is right here? So now where does point P fall on this line? Well, think about it. I have found the angle that I'm talking about, and the directed distance is 2. That means from the pole, from 0, you're going to go out 2 spaces. Well, what are those 2 spaces? Do you see these circles that are inside of your polar coordinate system? Each circle counts as 1 space. So there's, from the origin here, there's 1, 2, 3, 4, 5, 6, 7, and it keeps going on and on and on and on and on. So I want the point 2 comma pi over 3. So I go to the pole on pi over 3, and I'm going to go right here, 2 rings out, and there is my point P. So in a minute, we're going to talk about how we can find the same point in a different way. Well, think about it. If I want point P and I add one whole circle to it, do you guys agree? I'd end up right back here in the same spot, but we'd be at 2 comma 7 pi over 3. I could subtract 2 pi from pi over 3, and I'd get at the same spot. Now, another thing I want you guys to understand, like if I did that, okay, so say I said pi over 3 minus 2 pi, which would be 6 pi over 3, I'd get negative 5 pi over 3. So you could also say that this point is 2 comma negative 5 pi over 3. If you're given a negative angle, think about where you would go. If I'm right here at 0, if my angle is negative, instead of going up, I would go which direction? Down. Good. So you would figure out where 5 pi over 3 was and then go the opposite direction. Another way you could do it is if I look at this and say, okay, look at this line right here. Because we're all about directed line segments, right? Okay, so look here. Along pi over 3, okay, down here, I'm at positive 4 pi over 3. Everybody see that? All right, so say I'm looking at this point right here. I'm going to call this Q. All right, so what would you tell me from the pole? What is this? Well, from the pole, point Q is at 4 pi over 3 is the angle, and the directed distance that I went was 2 out. Okay, perfect. Well, another way that I could call Q as 2, excuse me, 4 pi over 3, how could we use, do you think, negative? What do you think a negative would do if this were a negative value? So let's look at this. If you're going towards the angle, that is a positive. So what would you say that going away from the angle would be? You could also name that a negative angle. So I could look at point Q and say, not only is Q 2 comma 4 pi over 3, but I could also say that Q is angle pi over 3, but negative 2. Think about that. I go from the center and I go away from pi over 3. I go the opposite direction. Same way we could call P, not only is P 2 comma pi over 3, right? We look at pi over 3, we go 2 towards it. We could also say that P is the angle 4 pi over 3, and instead of going 2 towards it, we go to the opposite direction, which would be negative. So those are just some things you guys got to look at. It's the angle that you're looking at and then the direction to or from. So like this, my angle 3 comma negative pi over 6. So think about this, negative pi over 6. We're going to start at the origin, and here is my polar axis. Well, where is negative pi over 6? Same way that we found this the other day, or not the other day, but in chapter 4. First, find positive pi over 6. It's up 2, right? You go 1, 2. So negative pi over 6 would be down 2. So it's right here. This would be my negative pi over 6 right here. So another way that we could write 3 negative pi over 6, we could also say 3 comma positive 11 pi over 6. Those are the exact same spots, because you're going to go from the origin, you're going to go 3 spaces out, 1, 2, 3, and there's your point. We'll call this A. We'll call this point A. But since this angle is negative from the polar axis, instead of going up to pi over 6, we went down. So these two are the exact same values. You could say those are the exact same things. Now, if you wanted to find another way to name this point, well, here is my 11 pi over 6. 11 pi over 6 also goes right here to 11 pi over 6 goes right here to 5 pi over 6. So another way I could say that is I could say, oh, okay, well, if I'm going to use 5 pi over 6 as my reference point, think about it. In order to get to point A, if I'm at the pole and I'm looking at 5 pi over 6, instead of going 3 towards it, I went 3 away from it. So it would be negative 3 comma 5 pi over 6. All of those are the exact same thing, guys. It's important to understand that from the pole, you can go towards the angle, which is a positive directed distance. You can go away from the angle, which is a negative. You could also add or subtract 2 pi and get into the exact same situation. One thing I want you guys to be aware of is just say, let's look at the point if I have what, negative 2 comma 3 pi over 2, right? So that means I find 3 pi over 2. I'm at the pole. We're going to call this J, whatever. So think about this. This is going to go away since it's negative. So 3 pi over 2, I'm going to go away 2 spaces. I'm going to put it right here. What's another way we could call negative 2 comma 3 pi over 2? Well, that's the same as saying positive 2 comma, what direction or what angle do we go towards? Pi over 2. So it's all about the direction. If it's a positive directed distance, you're going towards the angle mentioned. If it's a negative, you're going away from. Another thing I want to bring to your attention, guys, is if you have, say you have 0 comma pi over 2. Well, think about 0. If you're at 0, the directed distance that you're moving towards pi over 2 is 0. This is still at the origin. This is at the pole. What about if you have 0 comma 4 pi over 3? Well, where is that point going to land? It's still at the pole, because your directed distance away is 0. What if you had 0 negative 147 pi over 2? That's not anywhere on the unit circle. You would not have to do any sort of math or anything like that. You would just have to say, wait a second, my directed distance is 0. We're staying right there at the pole. All right, let's do one more. And this is so much easier when I do it on Notability. But if I erase here on the video, then everything erases. So I'll just do a different color. Let's say I have the point 5, negative 5 pi over 6. So 5 comma negative 5 pi over 6. Well, where is negative 5 pi over 6? Well, let's find positive first. So starting at the polar axis, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 5 pi over 6 is 10 units up. So to find negative, I go 10 units down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here. All right, there, 5, negative 5 pi over 6 is the same as 5 comma 7 pi over 6. So where is that point? Where you start at the pole, you're going to go towards, because it's positive 5, so 1, 2, 3, 4, 5. There's my point. We'll call this M. That's point M. Well, what's another way I could name this point? Well, from the pole, I noticed that 7 pi over 6 is on the same line as pi over 6. So if I wanted to go to point M, and I'm using pi over 6 as my angle measure, I would say it's negative 5 pi over 6, because I'm going 5 spaces away from. So there's 3 representations for the exact same point, just using positive and negative directed distances or angle measures. And then to find coterminals, you would add and subtract 2 pi. Okay, so we kind of covered this a little bit at the beginning, but it says right here that in your rectangular coordinates, your x, y, each xy point has a unique representation. There's only one spot for it, but that is not true with our polar coordinates. Because if you add 2 pi or subtract 2 pi, you'll end up in the exact same spot. That's one whole circle. You'll end up with a different angle measurement, but the exact same spot. Another way we just talked about to obtain a different representation is to change. If you have a positive r, you change it negative. You go the opposite direction, and you go half of a circle away, which we've already talked about. This is just I'm just putting the math behind it here. Let's look at this again. Again, if you want to go, in general, you can say if you want to go one whole circle around, you're going to add, if you want to keep your r positive. If you want to go halfway around and make your r negative, then you go half of a circle away. So let's talk about that for a second. I have the point 3, negative 3 pi over 4. So there's a bunch of different ways that we can find additional points for this. And this little constraint here is going to give us a little bit of a hiccup that we're going to have to talk about. But let's first talk about where the point, and we'll call this point, let's call this point R. All right, let's find R. Where is R at 3, negative 3 pi over 4? Well, we're going to start here at the pole. Negative 3 pi over 4. Well, let's figure out where positive is first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go from the pole, the polar axis, I'm going to go 9 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here at 5 pi over 4. All right, so let's think about different ways that I can write this point. Not only do I have 3, comma, negative 3 pi over 4, I also have 3, comma, 5 pi over 4. Does everybody agree? That's the exact same spot on my polar coordinates. So I'm going to go 1, 2, 3, 4, 5. There's my point R. Now let's think of all the different ways that we could write this. I could add one whole circle. I could add 2 pi, come all the way around and be back at that same spot. Or I could add just a half circle and be over at pi over 4. The only thing that's going to change there is my R value. Instead of being positive 3, it's going to be negative because I'm going away. So I could also write this as the angle pi over 4. But from the pole, did I go towards pi over 4? No, I came away from it. So it would be negative 3. Why did I put this at 5? This should be a 3. Sorry, guys. My brain's not working this morning. I'm at school and you guys are all at home. So now, okay, here's one representation. Here's a second representation. I need to find another because it says 3. So how would I find another representation? Well, I could add and subtract like we just talked about. I could add and subtract a whole circle, or I could add and subtract a half a circle. It's just depending upon if I want to keep my R value positive or my R value negative. This constraint tells me, though, I have to be careful. Whatever this third representation is, it has to be smaller or in between negative 2 pi and positive 2 pi. So let's see. Let's see what we have here. We're going to start off with our original of 3, comma, negative 3 pi over 4. All right, I'm going to keep my R value positive, so I'm going to add one whole circle. If you guys agree, 2 pi, if I change it into fourths, would become 8 pi. So if I add 8 pi over 4, I end up with 3, comma, I end up with 3, comma, 5 pi over 4. Well, we already have that one, so good to go. So now let's say, okay, well, let's subtract. Let's see what happens when I keep 3 positive and then I subtract one whole circle. Minus 8 pi over 4. So I end up with 3, comma, negative 11 pi over 4. Mathematically, that is correct, guys. No problem. But this constraint tells us, wait a second, it has to be in between negative 2 pi and positive 2 pi. If I look at this, 4 goes into negative 11. It goes in negative 2 with a little bit left over. So this is smaller than negative 2 pi. We can't use it. So now I'm going to say, all right, well, let me change the value. Let me change my r value to negative. And then I'm going to add and subtract just 1 pi. I'm only going halfway around the circle instead of the whole way around. So I'm going to say negative 3 pi over 4 plus, well, if I have 1 pi, if I change that to 4, so it's 4 pi. So I have 4 pi over 4. This is going to give me negative 3 comma pi over 4. Oh, look, we already figured that one out. So, okay, good. So I still have to go through a little work to find a little more, one more representation. So I'm going to say negative 3, and I'm going to take my negative 3 pi over 4 and subtract 4 pi over 4. Let's see what we get here. So we get negative 3 comma negative 7 pi over 4. Is that in between negative 2 pi and positive 2 pi? How many times does 4 go into 7? It goes in one time with a little bit left over. It does work. So here's our other representation. So what I want you guys to take from that is if you're going to keep your r value positive, if it is positive, you want to keep it positive, you add and subtract 2 pi. If you're going to change the sign of r, if it's positive, you want to make it negative or vice versa, you're just going to add or subtract pi. This is one whole circle to go all the way around to the same spot. This is a half a circle to where it changes your direction. Instead of going towards the angle measured, you're going to go away from it. So we'll practice this a little more next week. On Tuesday, we're going to do section 9.5, part 2. And then Wednesday, we're just going to practice all this stuff, and it'll be much easy for you guys to see. All right, have a great weekend.